Welcome back. In this video lecture, we will see cross-site scripting overview. Cross-site scripting vulnerability. It's a client-side attack and it's most popularly called as XSS. So, cross-site scripting vulnerability is often found in a lot of web applications, especially where a user provides input receiving areas like search forms and feedback forms. If the user supplied input is actually being executed by the web application, which means that web application is cross-site scripting vulnerable. The user provides JavaScript code instead of providing a legitimate text. And if the JavaScript code is being executed by the web application, which means that web application is cross-site scripting vulnerability can also be used, and in order to stolen user cookies, session IDs, and even it can also lead to CSRF attack. So cross-site scripting is of three types. The first one is reflected cross-site scripting and the second one is stored cross-site scripting and third one is DOM-based cross-site scripting. Now let's talk about both of them in much more detail. Reflected cross-site scripting is also called as non-persistent cross-site scripting because here the user input is not stored in database, which means if the user input is not stored in the database, the response of the web application is only shown to the user who is actually injecting the JavaScript. Which means if we are injecting something in search bar or our JavaScript is being executed by that application, which means the response of that JavaScript can only be shown to us, not anyone else, because the input is not stored in the database and often found in the search bar. Okay, now let's talk about stored cross-site scripting. So stored cross-site scripting, also called as stored XSS and persistent XSS. Why? Because the user input is stored in database, and once the user input is stored in the database, then there are just for example there is one comment section and we commented out a JavaScript query, and in place of comment we added JavaScript queries and we will click on submit. Anyone visit that page, then the JavaScript also being executed on that user, which means the impact of stored cross-site scripting is much more than non-persistent cross-site scripting, and then it can also lead to CSRF attack. Now let's see that DOM-based cross-site scripting. DOM-based XSS simply means a cross-site scripting vulnerability that appears in the DOM, means document object model, instead of part of the HTML. In reflective and stored cross-site scripting attacks, you can see the vulnerability payload in the response page, but in DOM-based cross-site scripting, the HTML source code and response of attack will be exactly the same. That's all about XSS. Thanks for watching and see you in next class. Welcome to our video lecture. In this lecture, we will see that how XSS vulnerability found in the reflected search result form input. For this demonstration, I will use OWSP Mutual Day to broken web application. Before going to start, first ensure that Burp is correctly configured with your browser. Let's open up XSS DNS lookup page to test for XSS vulnerabilities. Let me check how this web page works, means behavior of this page. What I am going to do is let's search DNS lookup for google.com. Type google.com and hit submit. Here you will see over here that we get search results. In this course, we have not concentrated on DNS lookup results. You can see over here that resulted for google.com. So let me inspect this page. Okay, here you can see that division tag results for google.com. Here no JSON or nothing. It is directly displaying. So google.com is searchable. Suppose if the search item is not found, it is displaying the same. So let's check it once. Check for random item. Here you can see that it is same here. For this XSS we don't have any problem, right? So let me open up Burp Suite and intercept is on. Search item. Here you can see that Burp is intercepting the HTTP request. This is the post request, action for URL, and so on. So I will send it to repeater for analyze request and response side by side. Click on parameter tab. We can input various XSS payloads into the input field. So what I'm going to do is I will add one simple XSS payload as open script alert XSS closing script. This example we have used a payload that attempts to perform a proof of concept pop-up in our browser. Now click on Go button. Here you can see over here that in the response we can assess whether the attack payload appears unmodified in the response. If it exists, this means that application is vulnerable to XSS. You can find the response quickly using the search bar at the bottom of the response panel. The highlighted text is the result of our search. So right-click on the response to bring up the context menu. Click Show Response in Browser to copy the URL. Click Copy. Now paste the copied URL in the browser. Here you can see that we have successfully injected JavaScript into the web application. It's a simple one. In the next lecture, we will try with a DVWA vulnerable app with check all the security levels for XSS vulnerability. If you have any doubt on this lecture, I will update another lecture with by passing the HTML tags to run our JavaScript. Thank you for watching. See you in next class. Welcome to this video lecture. We will see how to find cross-site scripting vulnerabilities with different security tools. In previous lecture, we have learnt about XSS overview. Okay, now let's see one simple example to find XSS vulnerability. Let me open up DVWA vulnerable web application. In this lecture, I will demonstrate with security level low, medium and high. Here you can see that security level is low. Now click on XSS reflected. You can see that this is reflected cross-site scripting vulnerable page. So first of all, let's try to add a normal text to analyze behavior of this page. Type XSS, hit submit button. Here you will see that we get response as hello XSS. This web page will display input what I have sent to web application. Now let me try, is this page vulnerable for accesses or not? What I'm going to do is, first I will send accesses payload, means JavaScript code, tap script alert accesses vulnerable as message and closing the script. Hit submit button. Here you will see that we got pop-up message. You can see that we have successfully able to execute JavaScript on this page. This means that this page is vulnerable for accesses. Let me show you in source code. You will see here in pop-up source code, it is directly displaying user inputs. Now I am going to change security level as medium. Let's see what happened. Here is DVWA security select as medium and hit submit. You can see that in top of the page, security level is currently medium. Click on accesses reflected. Let's see that is this page vulnerable for previous accesses payload or not. Type open script, alert accesses vulnerable and closing script. Hit submit button. You see that this payload is not vulnerable for this page. Let's see the source code of this page. Click on view source code. You can see over here that developer added some statement as str replace script replace with null character by getName. In the PHP str replace function will replace only those characters which appear in the string. So what I'm going to do is, I will add same accesses payload, but there is one trick, that is, developer doesn't concentrate on the case sensitive payloads. So send a payload with small and big letters. Tap opening script, alert, accesses vulnerable and close the script. Here you can see that we have got pop-up message. This page is vulnerable for accesses with case sensitive. Now we are successful using with 2-level security. So change security level as high. Now let's try with low-level accesses payload. This payload is not working in this page. So let's try with medium level payload. Okay, this payload is also not working. So let me open up PHP source code of this page. Here you can see that developer preg replacing each character with null value as SCRIPT pattern, as I have told you earlier in the accesses overview lecture. We can also find accesses vulnerability in DOM. It means document object module. So let's try to execute JavaScript in DOM. Type image src equals to and hit submit button. You can see that this has worked. Type image src equals to x and mention the attribute like on error equals to alert function accesses vulnerable. Hit submit. Here you will see over here that pop-up message. In this lecture, we have learned how to find accesses with low, medium, and high-level security. Using this lecture, you try it in stored accesses also. It will work successful. But the thing is, in stored accesses, all the payloads that you have submitted to server, all these payloads are stored in the database. But the question arises is, what is the use of this vulnerability? Is it a security issue? How attacker can exploit this vulnerability? In the next lecture, we will see how attacker can exploit this vulnerability. Okay, that's all about this lecture. Thank you for watching and see you in next lecture. Bye-bye. Welcome to our video lecture. In this lecture, we will talk about how they access vulnerability in our real life and how to prevent them. Let me explain the process and the impact with an example. Imagine that it is a Sunday morning and you receive a call from your mother. Mom is so scared because all the money in her bank account has been stolen. You, as a good son, enter the online bank application and review the account. When you see all is correct, but there is a transaction that moved all the money to another account, when your mother calls the bank just answers that this transaction was executed with her valid credentials and is not possible to do anything because all is correct. Now the question rises, how did this happen? You discovered that a day ago she received a message by email from the bank to win a vacation in Paris. She logged into the website and following the recommendation that you as a security expert gave to her, she checked in the web browser's address bar that the bank's domain was correct. She called the bank again to confirm this promotion, but the assistant tells her that no one in the bank knows about the promotion. You know what happened now? Your mother was the victim of a reflected access sent by email to steal the credential of her bank account. Reflected access is a type of access that is executed at the moment. Mostly, it affects GET requests. If you examine the email received by your mother, you can see that the email contains a link to the promotion. This link includes the valid bank's domain name, something like this. Here, www.bank_domain.com/access account equals to, then single quote, script, alert, and blah blah. The value assigned to the variable does not appear like an account number. It actually is a JavaScript code. You can identify it by the script tag, which is the tag used in HTML to insert a code script. Now, you can infer that the account variable is vulnerable. It has a lack of input validation that allowed an attacker to inject JavaScript code and send a lot of emails with the malicious link to people in order to execute the attack. This is the reason why this type of exercise is called first order. But if you enter the real URL without using the malicious link, you will not see the attack. The attack just affects the user who is clicking the link. Whenever you get spam emails, don't click on the links without verifying. Check it once, is this link contains JavaScript or not? Or some links will redirect to malicious websites or malware download links. Okay, thank you. See you in next lecture.